Hey, welcome back. This is Unit 7, Topic 5. This is the second part of the video. In this one, we're going to cover example 1. We're going to solve the quadratic inequality algebraically. So we have methods available to us that we've gone over. We can solve a quadratic by factoring. We can solve it by taking the square root. Okay, when we take the square root, that just simply means we do not have a linear term. So it involves, just basically setting up so we can take the square root of the value. CTS, that just means complete the square. So we can complete the square, which then evolves into just taking the square root of something. And then, of course, we have the trusty quadratic formula. So if I look at example A, I'm looking at the problem. I see x squared plus 9x less than or equal to negative 20. Now, I I'm looking at the problem and I see like the 20. I can think of factors that are going to give me 9. So I'm immediately going to go into using the factoring method. I can choose any method that I really want to use outside of maybe taking the square root because I have a linear factor. So I can't just simply take a square root. I would have to do maybe complete the square instead if I wanted to go that route. So in this problem, let's just go ahead and set it up for this factoring. So I'm going to go x squared plus 9x is, and then I'm going to move the 20, so it's be plus 20 and set it equal to 0. So I'm going to change the inequality to an equal sign. Then I'm going to take two factors of 20, that gives us 9x. I'm going to rewrite 9x as the sum of 4x and 5x. Because 4 times 5 gives me 20, 4 plus 5 gives me 9. Okay. Next, I go factoring by grouping. I'm going to get x times x plus 4 plus, and then the second group, we have 5 times x plus 4. Okay, next, I'm going to see that I have a common binomial, so I'm going to factor that out. We have x plus 5 times x plus 4 equals 0. Now, I have my two sets of factors set to 0, so all I got to do is take each factor, set it to 0, and solve each of them independently. So this becomes one of my possible factors is x equals, well, that would be incorrect because I'm supposed to write plus 5 here. So x plus 5, so I'll go x equals negative 5. So that's one of my critical points. Then the other one, x plus 4 equals 0. We would say x equals negative 4. So my second critical point would be negative 4. Guys, so now let's set up the number line. So the number line goes, and we'll have negative 5 to negative 4. The inequality sign that was given to me was the less than equal sign. So what I want to do is have some closed points. So we'll go ahead and set these up. I like to draw them above it. More than welcome to do this on the number line itself. Then what we're going to do is we're going to pick values that are to the left, in the middle, and to the right of our critical points. And the easiest way to do this is to choose a good whole number or good integer that we can use. So for negative 5, to the left of that, I like negative 10 because it's easy to multiply things by 10. Between negative 5 and negative 4, there's not another integer. So we're just going to have to go with, um, let's split it down the middle. So let's go with negative 4.5. And then on the right side of negative 4, we're going to test, let's go with 0. 0 is always a good one. If you can get 0 in there somewhere, you want to try to use that. So now what we got to do is test each of these 3 points. So I'm going to take the first one, the negative 10, we're going to test it out. And what we're going to do is we're going to throw it into the original inequality. So x squared plus 9x less than or equal to negative 20. So x squared would be negative 10 squared plus 9 times negative 10 is less than or equal to negative 20. Okay, if we go through the math, we end up with 100 minus 90. And then from this, we get negative or positive 10. Is 10 less than or equal to negative 20? No, it's not. So that would be false. So we would reject negative 10 or anything to the left of negative 5. Okay, so we will not include that as part of the solution set. Then we're going to test negative 4.5. Okay, so we're going to go negative 4.5 squared plus 9 times negative 4.5. Is that less than or equal to negative 20? Well, negative 4.5 squared, that's going to be positive 20.25. 9 times negative 4.5 is minus 40.5. Go to my color here. Okay, and then we say, okay, well, this reduces down to negative 20.25. Is negative 20.25 less than negative 20? Absolutely. So this, there we go, move that in there. This is the solution region that we want to include. And then finally, we'll test the last point, just for clarity here. So we're going to test, the last one was going to be 0. So we're going to go 0 squared plus 9 times 0. Is that less than or equal to negative 20? Well, if you think about that one, that's just 0 plus 0, which is 0, and 0 is not less than negative 20, so this one is false. So we're going to reject to the right and to the left, but we are going to accept the middle. And it's inclusive, so we want to include it all. Okay, so let me move this down just a little bit. So our final piece is to write the actual inequality that represents this. So we have x, or I'm sorry, negative 5, which is less than or equal to x, which is less than or equal to negative 4. Okay, that's one way to write it. Or we could also just write it as, and this is not like an inequality, but we're going to say x is greater than or equal to negative 5, and so that use the intersection symbol, x is less than or equal to negative 4. So one of those two ways works just fine. We could also use interval notation. Interval notation would read out as bracket negative 5 comma negative 4 close bracket. So one of these three ways is perfectly acceptable. Okay, that is it for this video. So I will see you in the next in example B.